Okay, let us read this problem. So this is something around kinetic energy, temperature and pressure calculation, kinetic theory of gases, something related to kinetic theory of gases. So let us say what we have. So this problem says we have a cubical box that is given to you. So let us say we have a cubical box here. This cubical box, each side of 1 meter. So this has a 1 meter side, this is also 1 meter side, and the perpendicular length, that is also 1 meter. So this is a cubical box, you see. So this side is also 1 meter, and this is a cubical box. Now you see the problem says this contains helium, and helium has atomic mass of 4 gram, that is also given to you. Inside this there is a pressure, and the pressure is also given to you. Pressure inside this cubical box, and in terms of SI unit, so this pressure value is given to you 100 Newton per meter square. So this is given in SI unit. Now see, question says there are some molecules, a molecules that is moving parallel to one of the side makes 500 collision in 1 second. So this gives on average, so this is root mean square speed parallel to one of the edges. So this is RMS. So it says root mean square speed. So this says something about root mean square speed. So this is root mean square speed. So you see this says it makes 500 collision. So 500 collision in 1 second. In 1 second. So what is happening, you see, this is the ball. So you see here, so you have one ball of the cubical box, this is another ball. Now this molecule goes from here and this collides with this ball, comes back, and then collides, goes, comes, collide. So this goes on. So in 1 second there are 500 collisions. So what is the time required for one collision? So time for one collision, that is collision frequency, you can say time for, not for collision frequency, collision time, you can say time for one collision. So this will be, so 500 collision requires 1 second, so one collision will require 1 by 500 second, obvious. Are you getting or not? Now the question says how much distance is traveled to for one collision. You see, if this molecules collide here, then it will collide again. So let us say this molecule is coming and it collides, then goes back, this goes back, and then comes. So if it collides with this, it has to travel a distance 2L. So this distance is 1 meter. So it has to travel a distance of 2 meter. You see what is happening. Let us say this molecule just is here, is somewhere here, and this has collided. This is t equals to 0. So I said t equals to 0. This molecule has collided with this ball, and now this goes back, collide with this ball, comes back, and then collide with this ball again. Are you listening or not? So you see what is happening for this collision and this collision. There is a total distance traveled is 2L. So this is 2 meters. So this goes here and then comes back, then collides. So for one collision, distance traveled is 1 meter. So you see between one collision, so during one collision, distance traveled is, this is one important point we have in this problem. During one collision, distance traveled is 2 meter. So this is the distance traveled. So distance traveled is 2 meter. Are you getting it? So now I can calculate the velocity. Now this velocity will be root mean square, because the question says it is traveling with root mean square speed. So we can calculate Vrms, that is the distance divided by time. So you have distance divided by time. So you see what is the distance. So we have distance is 2 meter, and what is the time? 1 by 500. So this value comes out. So distance is 2 meter and this is second. So velocity will be meter per second. So 1000 meter per second is the velocity. Are you getting? Now the first part of the question says evaluate the temperature. So we have to calculate the temperature. So what is the temperature? If you remember, we have expression for Vrms. Vrms is 3 by 2. This is 3 by 2 RT by M. and this under root 3 by 2 or 3 RT. Yeah, this is 3 only, no 2. Did you remember? So there is no 2 here you have, so I have to rub this 2, no 2. So this is simply 3 RT by m. So what expression we have? We have expression for kinetic energy VRMS, that is 3 RT by m. Now I know VRMS, so we can calculate temperature. So what is RMS? 1000. So this is 1000 meter per second, and this is under root 3 RT. So 3, and question says value of R is 25 by 3. So you see the problem. This gives SI unit for R is 25 by 3. You see here. So this value, so this gives 25 by 3 joule per mole per Kelvin. So you see, if I plug this value here, 25 by 3 joule and per mole, and this is per Kelvin also. So this is per mole per Kelvin, you see. And what is the temperature? So temperature we have to calculate. And what is the molecular mass? That is 4 grams. So I have to write in SI unit, that is 4 gram is 4.10 to the power minus 3 kg. Now only thing is I have to solve for T. So if I solve for T, what I will ask, this is 10 to the power 3 raised to the power 2, so 10 to the power 6 multiplied by this goes 4 into 10 to the power minus 3, and you will have divided by, so this is 3 goes, so simply 2, 25, simple calculation. Are you getting or not? So this is 10 power minus 3, so you have 4 into 10 to the power 3 divided by 25. So we can calculate this value. So let us calculate this value. So we have 4000, so you have 4000, 4000 and divided by 25. So what this value comes out to be? So this comes out to be 160. So you have a temperature, so final temperature. So temperature in this box, cubical box is 160 Kelvin. So this is your part A. Now let us discuss part B. So what the part B of the question says? This says evaluate the average kinetic energy per atom. So average kinetic energy. So you have a monatomic gas. Helium is a monatomic gas. So helium you have here. It's a monatomic. So we have an expression for monatomic gas. Kinetic energy is given by 3 by 2 kT for one atom. And now we have to calculate the calculation. So 3 by 2, K is given to you. See the problem, K value is given to you. So K value is 1.38 10 to the power minus 23. Plug here. So 1.3 at 10 to the power minus 23. So this value is 1.3 at into 10 to the power minus 23. And temperature we have already calculated. So this is 160. So I will have 1.5 multiplied by 1.3 at multiplied by 160 multiplied by 10 to the power minus 23, and this kinetic energy will come out in joule because we have taken everything in SI unit. Let us calculate this value. So 1.5 into 1.3 at and then multiplied by 160. So this comes out to be 331.2 into 10 to 331.2. So this value is 331.2 into 10 to the power minus 23 joule. If I wish, I can also write 3.31. So let us say I can write something like this, scientific notation 3.312 into 10 to the power minus 21 joule. So this is the answer of part B. Now what is the part C says? So part C of the problem says evaluate the total mass of helium gas inside the box. So this time, if you can calculate the total number of mole, things are basically done. So we have to calculate total number of mole for part C. That is, you can apply PV is equals to nRT, and the question says inside the box pressure is 100 Pascal, and R is given to you 25 by 3. Are you getting or not? So we can, and temperature I know that is 160 Kelvin. So let us work in terms of SI unit because everything is given in SI unit. So pressure is 100 Pascal we have, and volume that is 1 meter cube because 1 meter. So 1 meter cube you have N. So we have to calculate N. So I will have N and R is 25 by 3 SI unit. This is 25 by 3 joule per Kelvin per mole. So you see, so this is, so you see SI unit for R that is given to in the program. So 25 by 3 joule per mole per Kelvin. So I can plug this value 25 by 3 here. So I will have 25 by 3 joule per Kelvin per mole. So this means Kelvin and mole will come into the denominator, and T is 160. So from here we can calculate N. So N is what? So you have 100 multiplied by 3 and this divided by 25 and into 160. So this is the number of moles. So let us calculate this value. So easy one. 300. So we have 300. So this 100 into 3 into 100 is 300. 300 divided by 25 and then divided by this divided by 160. Are you getting or not? So this value is 160. So this is, let me write something like this. I can plug here a small bracket and then I have to multiply into 160, 160. So this value, 0.075. So this value comes out to be 0.075. So I have mole is 0.075 mole. So we can calculate the weight. So what is the weight of helium? So that is the cost in the program. So weight of helium is, because the atomic weight is 4 into 0.075. So this value is how much? 4 into 0.075. So this is 4 into 0.075. So this value is 0.3. So you have 0.3 gram of helium. So very low mass. So this contains only 0.3 gram of helium. Are you getting or not? Simple one. So you have the three parts of the question.